Dr. Fleischman.
Yep.
So I had a sort of question/comments that's very related to Visual's comment. When you were trying to match this in the very first step, you were mentioning that besides moving magnetic field and non-thermal electron density, you could decrease the area and decrease the non-thermal density as well. So in practice, students are going to have some options of changing combination of parameters, not just one, right?
In principle, yes.
Right. So I guess sort of my or students' question should be that they're going to have this document of which parameter is going to change more or less, but then when you actually try to fit the spectrum, are they going to, if they have like two options to do fitting, are they supposed to do two of them and see, or should they make some assumption about something and then choose just one of the options? Do you get my question?
Yeah, and the ultimate answer on this question is unknown to anyone because we really don't know what really happens. We want to investigate and we want to isolate and, for example, get rid of some of the options. We likely won't be able to tell absolutely confidently which single parameter made this change and which didn't, but we will have an ability to tell that sort of models is consistent with the data and not just the one. But in particular, my approach would be is to try to make changes in the way as simple as possible. In my example, for example, in particular, I changed time roughly for 1 minute compared with papers here at 17:45:53, and in the paper, the time frame was like 17:45:09. And you remember that first steps did not result in spectra very much different from the original. So, and to match next and or the following spectra, it would be possible with minor variation of many parameters or without variation of parameters at all. Then we wait roughly 1 minute and get this time frame and this spectrum. And to do so, to match this, I adjusted 2 parameters only. First of them was location of the non-thermal electron cloud along the central field line. I moved it a little bit towards stronger magnetic field. And the other one, I decreased the total number of non-thermal electrons. It was 8 there, and it became 5 here. And these 2 parameters, change of these 2 parameters, was sufficient to do this match. Now, we want to have all time frames to be matched. It's reasonable to assume that both these parameters varied smoothly or gradually between these time frames, and try to adjust all the sequence with just sequential small variation of this number between 0.3 and 0.35, and changing this number smoothly between 8 and 5. And if you do so, you offer a consistent story that the cloud of electrons slowly moved from one area in the loop to a little bit different area, and at the same time, the total number of electrons were getting smaller and smaller. This is a consistent story, which is in particular consistent with our expectation of behavior of trapped electrons. They evolve within the loop, and their number is being closed unless we accelerate or inject new electrons. And injection of new electrons will be seen as a new temporal peak in the time profile. If you don't see new injection, it's reasonable to expect that the number of electrons goes down and there is some special evolution of this cloud. And this is what I try to do. Here it was not possible to match new spectrum with changing only one parameters, but changing of two of them was sufficient. In such cases, I propose do not try to change 3, 4, 5 or more parameters. The smallest number sufficient to match.
Right. So it was based on the physical expectation. Yeah. What I was saying is that there was another option of changing another two parameters. That was the area and of the non-thermal electrons. But that option was going to increase the non-thermal electron density because you're going to decrease the area.
Yep.
So that's sort of like in the opposite direction of this. If as time goes by, the non-thermal density will not probably increase, but rather decrease. So that's why you chose this option. And
let's just try going that way. Let's come back to the same location. We want to decrease area, yes? Right. Put 12 here. It shrinks. And let's put original number of electrons. And this will be smaller area. Let's quickly compute it. And if we get equally nice result, or if we see an avenue how to reconcile spectrum with data, would be another option. Jello, the time is going to the end, and could you possibly reformulate the assignment I proposed to our students to make the documentation? Or this assignment is absolutely clear? I just want another formulation to make it absolutely clear what is it.
No, I think we have to tell them clearly that we expect to play with your code, yes, and try to change parameters and make a document in which they make notice of what's going on. I would suggest them to try to play with different parameters in your code and maybe do some screen captures and put them in a Word document, and they say, I changed this from this to this, this is what happened. And try to go to the list of parameters that you listed there. I wanted to make another point. If you go to the scanner page in your simulator and see that, you see here that actually is a list of parameters that are in the program and short comments telling you what each of them mean. Yes, just a reminder. So this can be also used like a source of information in addition with what is in the text. Maybe it's already in your code, but I did not.
It's in the code. It's in the code. The only problem is that this is parameter list with comments.
Yes.
And it starts from 0. In our check simulator table starts from 1.
Yes.
So just keep in mind that numbering here and here is different, just shifted by unit 1.
Okay.
I wonder, do we have questions from students because their time is ending?
Well, I was sort of in the middle of the discussion, I guess, right? So we did get the fit with the parameter change you made. I saw it. It's not as good as the other one, but how can
we can make it better, of course. We can try to adjust it, just move it a little bit here there because it was very quick fix along the line you suggested. I just made it. We go here, made it more. So what we have here, we made it more compact. This means that with the same number density, the total number. What happened with total number? Became smaller, and this is why I had to increase the number density by 50%. Yeah.
Right.
And let's see now in light curves. It's not very fine scale, but still, it seems that we are on the declining phase of it. So it would be more reasonable to assume that the number density goes down rather than it goes up. It cannot be excluded because, again, you see that the agreement is comparably good in that cases.
Right. So for students, though, they don't have this sort of background to judge which option, magnetic field plus the non-thermal or area plus non-thermal. So we should give them some guidance. That's the way we're thinking to go, right? Or at least how to judge.
One possible guidance would be to tell, let's consider one avenue to the end and then try the other one. And one another way of testing, like of evaluating if the choice is correct or not, is to take, as I said, in the beginning of the minute and at the end of the minute, the change of parameters, and then consider if all sequence of the spectra between them can be fitted with just gradual change of this couple of parameters. If you need some strong fluctuations or so, maybe it's not a good sequence of things. So there is no, it would be not a good idea, for example, to fit like next time frame with variation of one parameter combination, next one with another, and the next one with the third one. It would be always good to try to work with the same fixed pair or three parameters for entire or long fraction of evolution.
Okay.
It's just consideration of, let's say, reasonableness.
Yeah. I'm just a little worried about like how students won't be able to, physically sort of guide themselves to the right direction. There's no right or wrong direction, but this is a challenge of the forward fit that you can't. It has a lot of freedom, but then you can't just go anywhere. That's the thing. So.
Yeah, I believe that it's also a challenge for us because we have never done such exercises systematically, and we never considered. We do not have answers to the question to what extent and how long the same geometry, the same flux field will be sufficient to fit the data. We don't know that, and we want to get answers to these questions. I believe that we will be learning along with them.
And it will be, I think, very useful to have like discussion every day, at the end of the day, to see in which direction they went with the modeling and if it makes sense. Like I agree with what you said, that we have to have a consistent evolution of parameters and not jumping from one case to another. And I'm pretty sure that we can discuss and give them guidance, not necessarily we can guess something, give them some direction, but they can also try something different, and maybe we can make sense of what is going on. But yeah, we should. It's a very complex project. That's why we need we need to have a big team, and we have collaboration. We'll see how it works.
And again, nothing wrong if we offer like two possible evolutionary tracks for the same flare. It would be another interesting finding.
So maybe, Gregory, maybe it would be a good idea to try to, when they first come here, try to have some kind of presentation which a few scenarios can be shown, like about evolution. What is the expectation or at the level of knowledge that they have now? Maybe this is one way a flare can evolve, this is another way, and so have some kind of consistent scenarios, and this would require this kind of parameters to evolve in certain way. And even if what we study is not exactly one way, but at least it will be a consistent story that we maybe it's good to start with and to have some idea.
Okay.
Let's think about it. Okay, so I think it's time to end the meeting now.
Yeah. Any last minute questions or comments? If not, thank you very much, and let's meet for lunch in a while.
Okay.
Thank you.
Bye bye.